Hello everyone. In this, we will understand about variable in research, which is also called as research variable. Anything that may assume different numerical or categorical values or definite values, you call it as a variable. A characteristic or feature that is measured. For example, measuring heights of different people, that height becomes a variable. Similarly, capturing the data about salary of a company's employees, that also becomes a variable. A symbol to which values are assigned. Generally, we use variables x and y very commonly, which is considered to be a variable. And there, for x, you assign certain values and y, certain values are assigned. We'll be studying about all these different types of variables, which are continuous and discrete variables, control variable, decision variable, dichotomous variable, extraneous variable, independent and dependent variable, intervening variable, and moderating variable. Now we'll go one by one. Continuous and discrete variables. A discrete variable is a variable that takes on distinct countable values. For example, in probability distributions, we studied about binomial and Poisson distributions. Those two are considered to be a discrete probability distribution, and the corresponding variable is considered to be a discrete variable. So means it can only take integer values. It won't take any non-integer values, and it is countable. Means it is not like it goes to, it is uncountable. It can be counted very clearly. A continuous variable is a variable that takes on any value within a range. For example, negative infinity to positive infinity, like in the case of normal distribution, it is a continuous probability distribution. In that, the variable corresponding to that distribution is considered to be a continuous variable. Here we have an example. Suppose the fire department mandates that all firefighters must weigh between 68 to 80 kg. Then the weight of a firefighter would be an example of a continuous variable. Because the weight can be any weight in between 68 and 80. Means it can take like 68.4 can be a weight. 69.25 also is a possible weight. So you have infinite number of values between 68 and 80 because of those decimal numbers. Whereas if you consider tossing a coin several times, maybe 100 times if we toss a coin, and we have an experiment which we are doing just by counting the number of heads, the number of heads can be any integer between 0 and 100, because in all the 100 tosses, you may not get a single head also, it becomes 0. Or in all the tosses, there may be a possibility that everything you get head only. So it can be any integer value between 0 and 1. It cannot take any decimal values, like we cannot get 2.5 heads or 6.4 heads. So here we consider the number of heads as a discrete variable. Next one is a control variable. A control variable is anything that is held constant or limited in a research study. It is a variable that is not of interest to the study objectives, but is controlled because it could influence the outcomes. Variables may be controlled by holding them constant throughout the study, since it may strongly influence the results of the experiment. We will understand this control variable with the Boyle's law experiment, where there are three variables as pressure, volume, and temperature. There, if we keep the temperature as constant, we can understand the relation between pressure and volume. If pressure increases, what happens to volume, or if pressure decreases, what happens to volume. But if you don't control that temperature, or if you don't keep the temperature as constant, that may also influence in this pressure as well as volume. So that is the reason you are trying to control that particular variable, that is temperature, in that experiment. So what is the need for this control variable? Aside from the independent and dependent variables, all other variables that can impact the result should be controlled. If we do not control the relevant variables, we may not be able to demonstrate that they did not influence your results. In an experiment, a researcher is interested in understanding the effect of an independent variable on a dependent. That is the objective for any researcher. He tries to understand the effect of the independent variable on the dependent variable. He tries to find out a cause and effect possibility between these two. So control variables help us to ensure that our results are solely caused by our own experimental manipulation. This is the example what I was talking about, Boyle's law. So here P is defined as T divided by V, where P is the pressure, T is the temperature, and V is the volume. To test the resultant changes of any of the two variables, I was talking about what are the changes on pressure if I do some change in the volume, or if I do some change in the volume, what are the change in the pressure by keeping this temperature as constant. So that is what we saw, right? That is an example for this. Now, next one is decision variables. In linear programming problem, which we study in operations research, you have an objective function like this, maximize z, which is equal to 250x plus 400y. And then you have constraints subject to these constraints, 2x plus 5y less than or equal to 200, 4x plus 2y less than or equal to 240. So these two are considered to be a constraints. And considering these constraints, we are trying to maximize our objective, that is maximizing this z. So here decision variables describe the quantities that the decision makers would like to determine. So here the decision maker will be interested in determining the value of x and y. So that means this x and y are the decision variables which the decision maker would like to determine to get a maximum z, and at the same time satisfying the above constraints also, these two constraints. Next one is a dichotomous variable. From the name itself, we can understand that it can only take two values. So a variable that can only that have only one of the two values. Typically, you call it as binary, means typically 0 or 1, to designate membership in one of the two possible categories. Also called binary variable because it can take 0 or 1. You assign, when you assign the numbers, you assign 0 or 1. If presence means you assign it as 1, non-presence or absence means you assign it as 0. Indicator variable, design variable, categorical variable, or qualitative variable. All these are other names for this dichotomous variables. So for example, female or male, yes or no, head or tail, age above 35 or age less than or equal to 35, smoker, non-smoker, etc. Next one is extraneous variable. In an experiment, an extraneous variable is any variable that we are not investigating, but it can potentially affect the outcomes of our research study. If left uncontrolled, the extraneous variables can lead to inaccurate conclusions about the relationship between the independent and dependent variables. So we need to do something to not to have that impact of extraneous variables in our study. So what we need to do, we need to try to control the biases in our work. How do we do that? We'll understand that with an example. Let us suppose that a researcher wants to investigate the effect of a new teaching method on a student's test scores. Means if the researcher starts implementing a new teaching method, whether the scores are improving or not improving, or is it remaining the same compared to the traditional way of teaching. So the independent variable here, it is teaching method, and the dependent variable is the test scores. However, an extraneous variable that could influence the result is the student's prior knowledge of the subject. Some of the students might have already studied about that particular subject. That also can have an impact on the test scores. So in order to do something about it, what do we need to do? So the researcher selects two groups of students from the same school with the similar demographics. Group A is taught using the new teaching method, while Group B is taught using the traditional teaching method. Both the groups are given the same test at the end of the teaching period to assess their knowledge and performance, or basically to find out their test scores. The researcher analyzes and compares the test scores of Group A and Group B to determine the effect of the new teaching method. Then, what will influence the extraneous variable can have? In this scenario, the student's prior knowledge of the subjects is an extraneous variable that could affect the test scores. If Group A has students with a higher prior knowledge compared to Group B, it may lead to high test scores in Group A. So the extraneous variable could become a competing explanation for any observed differences in test scores between the two groups, rather than solely attributable to the teaching method. So to minimize the influence of that, what do we do? The researcher can implement strategies such as random assignment. That is one of the strategy. So wherein he can assign the students to Group A and Group B randomly, rather than knowingly assigning or having some bias in assigning. So randomly, he may assign students to the group A and group B, which may help ensure that any differences in the prior knowledge are distributed evenly between the groups and reducing the potential confounding effect. That is one of the strategy. The other may be like the researcher can also find out the prior knowledge before the teaching method starts, the new teaching method starts. Prior knowledge, how many students have prior knowledge? He can create some grouping. I mean, you can do what is called as a stratification he can do, or also called as a blocking he can do. That also another way, another strategy to avoid this impact of extraneous variable in our experiment. Independent and dependent variables. Consumers' attitude towards healthy lifestyle could impact their organic food purchase intention. Organic food, we know nowadays it is very popular, fresh vegetables or fresh fruits without having any chemical fertilizers involved in it. So if I should have a purchase intention to buy organic product, first of all, my attitude and also my interest towards a healthy lifestyle, that these two will definitely have an impact. Here, consumer attitude is an independent variable and purchase intention is a dependent variable. Dependent variable, you can also call it as an output, and independent variable, you can call it as an input. Dependent variable, you can call it as an effect, and independent variable, you can call it as a cause. This is one of the example given. Other example may be sale of a commodity may be considered as a dependent variable, and price is a independent variable, which can have an impact on the sales. Moderating variable, it is also called as moderator. It affects the strength and direction of a relationship. Again, coming back to the organic food somebody is studying, the strength of the relation between the attitude and the purchase intention might be modified by the education level and income variables. So here, even though you may have the attitude, you may have the purchase intention, but this will definitely matter, means education level of the person and the income level, because it is quite expensive compared to the regular food products. So here education and income are the moderating variables, or you can call these are the moderators which may affect the strength and direction of the relationship between attitude and purchase intention. Intervening variable, next one. An intervening variable, also known as a mediator or a mediating variable, explains the process through which two variables are related. For example, people with high income tend to have better medical care than those with low incomes because they can afford to pay for the medical care. So here medical care is an intervening variable. It mediates the relation between the income level as well as the longevity. This is intervening variable.